The last topic that we want to cover in this unit is image response. And so image response is an undesirable response that we need to consider when we're designing RF mixers. And so in order to get a better idea of what image response is, let's consider a simple example. So many FM modulators or FM receivers, so frequency modulated receivers, actually operate by down converting some RF signal to some intermediate range. So down converting, and so typically they're down converting from 88 to 108 megahertz, so somewhere in that range, to some intermediate frequency of 10.7 megahertz. And again, we want to down convert because it's going to be easier to do our processing at that intermediate frequency as opposed to these radio frequencies that are higher. So let's look at a specific frequency in this band here. So let's say we want to down convert some particular signal. So we want to down convert an 88.5 megahertz signal, and we want to down convert that to some intermediate frequency of the 10.7 megahertz that we mentioned above. And so let's say we want to do this using our low side down conversion. So low side down conversion. So with all of that in mind, the question then becomes, what local oscillator frequency should we use? So go ahead and pause the video for a second, think about that, see if you can't figure out what it should be. Going back to the previous video when we talked about this, we can see that our intermediate frequency range, or our intermediate frequency value, in this case the 10.7 megahertz, for low side down conversion is equal to the RF frequency, our 88.5 megahertz in this case, minus the frequency of our local oscillator. So that means our local oscillator frequency is lower than the RF frequency. Solving for that local oscillator frequency in this case, we get that it is 77.8 megahertz. So the issue of image response comes into play if we consider, well, what if there's another signal that's 10.7 megahertz below this local oscillator frequency? So let's consider what happens then. So if there is some other frequency, is some signal such that we have the local oscillator frequency minus our RF frequency is equal to 10.7 megahertz, then what happens is that this RF frequency here is going to be down converted as well. So this will also, and so let's maybe specify that as FR2, and so this will also be down converted. But it's going to be down converted to a different process. So instead of being down converted via low side down conversion, this is going to be down converted via high side down conversion. And so basically we see we're taking two things and doing two different conversions, but really we just wanted to be focusing on one. So in this case, if we plugged in the same local oscillator frequency here that we designed for this low side down conversion, we could see we would be running into issues if we had some other RF frequency at 67.1 megahertz. So if that was the case, we would have this image response. So there are several ways to sort of work around this, but our simplest solution is to just have some radio frequency filter. So our simplest solution is to just have an RF filter for inputs to our mixer. So basically, combining this with the idea from our previous video, we can see we want to have a filter on our input, so we make sure we're not doing unintentional conversion, down conversion. We're only doing either low or high side down conversion. We don't want to be doing both. And then we also need a filter on our output, because as we talked about, when we have the product of our local oscillator and our radio frequency, we get two frequencies. We get the difference of the two and the sum of the two. And so we want to filter out the sum of the two.